Welcome to the SOFiSTiK online documentation. In this video, we show how to post-process the results of the dynamic analysis. First, we will take a look at the time histories. As mentioned, we can use the result viewer to plot them. For this, we insert the task, interactive lists and graphics, select the histograms of interest and plot them. Next, we will show you how to graphically calculate and display a dynamic amplification factor. We insert the graphic task, open it, and create a page with 3 pictures. In this example, we will investigate the bending moment My. For a certain load train, we first take a look at the static envelope of the train passage stored with the extr command. Next, we display the envelope of the dynamic analysis with the maximum result for this train. The amplification between static and dynamic analysis can now be calculated directly in graphic. We use the option to calculate the quotient of 2 load cases to divide the dynamic envelope by the static one. Note that the maximum occurring static bending moment is 0 at the supports, while the maximum occurring dynamic results will be unequal to 0 due to inertia effects, leading to a high amplification factor. However, as the bending moment is anyhow small in these points, we can disregard them and focus, for example, on the span, where we have in this case a dynamic amplification of about 50%. Until now, we have taken a look at result envelopes for individual train passages. For the design workflow, respectively for comparison with the results of the static load models, we can build an envelope of all these envelopes, giving the overall extremal results of the dynamic analysis. For this, we use the module maxima. First, we define a rare combination. Next, we introduce all the relevant load cases to be considered. For this, we have assigned the result envelopes of the individual passages to an action MLT. Now we use this action to load all the result envelopes. Here it is important to define as type mutually exclusive in the superposition, so only the decisive load case is taken for the envelope. Finally, we request the superposition for the result of interest. Here, max bending moment My, and store the created result envelope to the given load case number. Now you can display the result envelope in graphic. So now we have evaluated the maximum dynamic results of all the train passages. If you more generally want to have an overview which train velocity combinations are the decisive ones or for which train velocity combination resonance effects might occur, we can take a result of interest, here for example bending moment My in midspan, and plot it for each of the dynamic analysis over the velocity. Here ranging from 40 meter per second to 80 meter per second. If we link the results for each train type, we can see which trains are the decisive ones and also see at the peaks in the plots for which trains at which speeds resonance phenomena occur. In the following sequence, we show you how to create this plot directly in SOFiSTiK. For this purpose, insert the task, interactive lists and graphics. Then we create a new table. To set up the plots, we need the following informations. From the system values, load case designation and load case number, and from the result section, bending moment My and the train velocity, which is used to store the speed of the train passage for the envelopes created by the MLT task. You can select all the tabs by clicking on them while keeping the control button pressed. Then we select the relevant load cases. Next, we select our position of interest, here for example a section in midspan. Now we can create the diagram. Go to the diagram tab and set up the plot. Select the train velocity for the x-axis and the bending moment my for the y-axis. For the creation of the plots, we need to specify which is the common information that makes individual load cases belong to the same graph. In our case, we use the load case title, which in the presented set is common for all envelopes belonging to the same train. Note that we have by intention set these titles in the MLT task for this purpose. Now you can go to Series and switch on the graphs. To distinguish the plots, you can select from a wide range of colors and line types. From the peaks in the plot, we can distinguish from which trains at which velocities resonance phenomena occur.